Welcome to the first Apache Karaf Meetup as a virtual meetup. We tried to plan it differently. Nevertheless, we were able to keep the timetable correctly, and so this is what we're planning right now. First of all, I welcome you all. I hope everybody has at least something to drink, a beer or wine or water. And I hope everybody is safe. This is the overview of what JP and others will talk about. And this is going to be our first meetup like that. We planned it differently. So let's see if that works out, and I'm open for any kind of feedback later on. So if there is anything that you want to say something or so, would be nice. I think with Zoom we're able to signal that, like raise a hand or something. So if you want to say something, so we can make sure that we see that and give you opportunity to ask questions.
If you want, Achim, you can move forward on the next slide. There's the ground rules. So basically,
wait a minute.
Go next. I tried to summarize.
Yes, let's screw that one up.
Oh, it was on the one that I shared with you.
I did. I just did. Okay.
Yeah, there's one. So, so just in addition of what Achim said, please be muted when you don't talk, because else there's some noises, and that could be painful for the others. If you have any question, don't hesitate to raise hands. So you can use the reaction button on Zoom. To be honest, depending the number of people, so right now we are 45 on the Zoom meeting. It could be pretty hard to address all of your questions, but we will try anyway. The presentation I recorded, as Achim said, so basically you can take the record to watch offline later. We will also send all the slides that we're going to use during this meetup. So you can, in my slides, for instance, there are some examples. So you can make a try yourself. And obviously, you can ping anytime after the meetup on the main list on Slack or directly by email if you have any question or focus you want to discuss about what we did during the meetup. I said to some of you before 6 p.m., this is a first edition. So obviously it won't be perfect or not as perfect as we want, but that's actually it's good to have one, and the purpose is also to prepare a second one. So don't hesitate to provide your feedbacks, to share your ideas, and something that we already discussed for the next edition is to be able to have some rooms dedicated to some topics. So for this first meetup, it's pretty straight. We have two talks, mostly two topics, general topics. But yeah, if you have a more specific points you want to discuss or standpoint or whatever, we can prepare something in the next meetup. Depending about your feedback on this first edition, we will see when the second one could stand. Could be maybe before the end of this year. It will depend a lot about your feedback. So Achim, do you want to take the lead now?
Okay, now I'm turned on again. Yes. Okay, the first talk that we will have is JB's talk about Karaf on the cloud. I think we're a little bit early on the schedule, though unless
maybe what we can do, Achim, is to do a quick introduction and give a chance to people to present people from a Karaf project. So, so I'm Star. So I'm JB. I'm a PMC member for Karaf. I'm actually the PMC chair of Karaf, working on Karaf since the beginning, almost. So yeah, that's a great opportunity to discuss with you guys that I know, some that I don't. So that's to see you there, and thanks a lot to be there. And so I give hand to Achim now.
Well, thank you. Well, let me quickly introduce myself. I'm Achim. I don't know what time I joined the project. It's quite some time ago. First contact has been around the web container at that time because it was really shitty, and I tried to improve that. And this is how I got into the Karaf ecosystem, and I just love the way the project works, the people are, and so forth. In my not so private time, I'm now working for a company that is giving us the opportunity to make this meeting happening with Zoom and so forth. And usually we would have presented you the surrounding as a non-virtual room to take place in. And so in these times right now, we just can do that virtually, and we will try to give you the opportunity to have the video offline later on. Yeah, maybe someone else want to introduce themselves. I don't know what the best way it is. It should maybe the list that I have here of the participants, or if they want to, or people want to raise their hands. I'm not sure if people want to talk or not. Okay, Paul did just raise his hand, so please go forward.
Yeah, I've been using Karaf since probably 3 point something. I do development in the manufacturing space, and we actually just use it to build bundles and put it on customer sites and run it that way. So it works out pretty well for us. We're doing a combination of some web-related stuff. So we've got some My Faces and Prime Faces based applications on the website, connecting to some systems that generate manufacturing data. And we pass that up to business systems like SAPs. So that's how we use Karaf.
Awesome, interesting, yeah.
Thanks. Someone else? I think that raise the hand is a pretty good way of acknowledging that you want to talk some. So next one, please.
Don't be shy.
So maybe I can follow.
Yes,
Yeah.
Christian. Yeah. Christian Schneider.
I've also been around with the Karaf project for quite some time, working on different parts of it. I used to work together with JB Talent. Nowadays I'm at Adobe, so not so much work with Karaf exactly anymore, but still a lot with OSGI, and so yeah, I'm still around.
Good to see you there. Remember talent time when we worked together. Yeah.
Yeah.
If you'll, okay, Dmitry, yeah, you raised your hand. If you're looking for the way how to raise your hand, sorry, it is if you go to the list of participants, and I think there you can say I want to raise my hand with Zoom. Otherwise, I'm not able to see all 49 people on my screen. Yeah, Dmitry, and I think Maurice also raised his hand. So Dmitry first.
Hi everyone, I'm Dmitry. I'm with Netflix, and we are very recent adopters of Karaf. and I'll talk a little bit more later today on how we use it and what we get out of it. But so far, I can tell we are enjoying this technology.
Thanks.
Awesome, thanks, Dmitry. And actually, so for the others, Dmitry will give the second talks about Karaf at Netflix and why they, in what way they are using Karaf Extra.
Okay. Maurice, is that correct? You raised your hand first, and after that, it's.
That's correct. Maurice, that's my name. I work for custom trade control for Gaston Schul, as is Stuart Brouwer, who's also attending today. We're using Apache Karaf as a main container and a cluster setup on the front end, back end, and ERP integration systems. So we're very happy at Karaf and trying to do a lot of enterprise integration, also with Camel and some other cool projects.
Thanks a lot. Next is, I'm sorry if I'm saying it wrong. Gregor, is it Gregor? I'm sorry.
Yes, it's Gregor in English.
Okay.
Hello, everyone. I'm Grzegorz. I'm from Poland. I work with Karaf. I came to Karaf mostly through JBoss Fuse product from Red Hat. I work in Red Hat, and I contribute to Karaf mostly not new features, but I usually fix bugs, low-level bugs. Recently, I work mostly on PAX projects like PAX logging, PAX web, and all the PAX components of Karaf. So I'm just contributor, not using Karaf, but developing Karaf.
Yeah, basically you're fixing the stuff I left you working with. That's good. All right, thanks. Browse, I hope I say that name correctly. Also, you're next.
Hello. Nice to meet you all. I'm Stuart Brouwer. First part of my last name, Brouw, Stuart Brouwer. And I work with Maurice, who just spoke. And I'm now trying some, I think, new stuff with the front end, which is Angular and Karaf. And also some Shiro with REST services, which is a very fun experiment, I have to say. And you learn a lot of stuff, which I didn't know I had to learn, but that's good, because new knowledge is always good, right? And yeah, I hope to hear some interesting things tonight. And now, you know, you always learn, so it's good. Thank you.
Thanks. Next one is Tony.
Oh, hi. Yeah, Tony Menzel. I'm one of the like older silent followers of Karaf, using it mostly in projects. My relationship is where I'm mostly original author of PAX exam and PAX URL. But the last 10 years, there wasn't so much like of stuff that I did in the open source world. But yeah, let's see what's coming up next. So yeah. That's it.
Thanks. Next one is Erwin, I guess.
Yeah, Erwin is good. Hi, my name is Erwin Hoogeweg. The last name is Dutch, obviously, but I live in South Florida for quite a while now. We started working with OSGI about 10 years ago, and about 5 years ago, we started a migration to Karaf for all the obvious reasons that it makes life of a developer a lot easier. Our biggest application is a community access control system. Here in South Florida, you have a lot of gated communities and access control. There's hundreds of communities here that have that system, and that's all managed from a central station here in South Florida. That's a traditional Java OSGI with a MySQL database. And then our other big application is a web application for a financial company, also with a MySQL database and an Angular front end. So that's our Karaf, those are our Karaf activities.
Cool, thank you.
Yeah.
Next one is DO46674.
Yeah, sorry, I'm unable to give this a reasonable name. This is my login name. I'm new with this Zoom stuff, so sorry. My name is Stefan Ciano. I'm working for SAP for a product. For a product called Cloud Integration. So this is also an integration project which is based also on Karaf, and it's running with Camo and CXF and this stuff. And I'm one of a very small team that has been building the Karaf runtime underneath the underneath this product.
Cool, thank you.
Cool, yeah, interesting.
Very interesting.
Actually, you are competing with other people on this call, so that's great.
Yeah.
Well, maybe next time you want to provide a talk. It would be very interesting. By the way, everybody should feel free to provide talks for the next round. Next one is Gerald. Is that correct? I hope.
Yeah, that's right. So I'm Gerald. I'm from Germany, and we have moved over to France 2 years ago. And I'm working for a small German company for integration. And we started a couple of years ago with Apache Service Mix and moved now on to native Karaf with Camel inside. And we are just in charge to develop a model-driven approach for driving Camel and integration scenarios.
Interesting, thanks. Yeah, man, I saw some emails from on the Camel mail list and on the Karaf mail list as well, so yeah.
Yeah, cool.
Yep.
Next one is Bernd. Or Bernd.
Hello, Bernd from Debugger. We're working on an integration server commercial package, which was originally running on JBoss, and we ported it over to Karaf because the platform is easier to maintain. And yeah, we are quite a few years on OSGI, and yeah, enjoy the travel.
And we were supposed to meet this week.
Yes, we are close to Karlsruhe, so we would have been there.
Yeah, next time for sure. Pretty soon, I hope.
Yeah. Next one is Kushal. I hope I say that correctly.
Okay, I was speaking with my mic mute. So, okay, so hi, my name is Kushal. So I'm not like that old acquainted to Karaf, but we have been using Karaf in since 2015 mostly for our data integration projects. So since last 2 years, we have been using Karaf and Apache Seller in one of our big integration projects where we are integrating around like more than 110 million records so far. And with Apache Camel, of course, so it's so far it has been a good experience for us. So yeah, it has given some good results, and then it's pretty stable. So yeah, hopefully I'm looking forward to this event today.
Awesome, thanks for sharing.
Thanks. We have one more. This is Rico.
Yeah, hi. Rico Neubauer, also from working with Seeburger, like Bernd before. So nearly the same story, working about 10 plus years with OSGI and migrated to Karaf. And yeah, JB, workshop this week did not happen. So I'm looking forward to in a few months.
I'm very sorry about that, but yeah, definitely in a few months, yeah. Yeah. With a lot of beers, but yeah, we'll see. All right, maybe to be back on the schedule, I propose to move forward and take maybe the introduction and question for after the two talks. I guess it works for you guys. So yeah, let's start with the first talk. So I will do this one. It's actually a talk that I did for ApacheCon. It was in Vegas last year. So the purpose of this talk is really to focus on some. I mean, I'm really bored in some companies, and especially one company where I'm working. A lot of people say, yeah, Karaf has been, OAGI has been. Now what we have to do is Spring Boot, because it's great for the cloud. And it's really frustrating because actually I think that with a little knowledge, it's possible to have a Karaf running on the cloud. At the end of the day, what we run on the cloud is a Docker image. Whatever we're going to use internally in this Docker image, it doesn't really matter for the DevOps. It's more for the developers what we want. So in this talk, I would like to quickly share with you the different way of using Karaf on the cloud. So why Karaf is interesting for the cloud? The first thing is, and is what people said during the introduction, is a runtime but where you can address a lot of different use cases. I heard a lot of you doing camel, some of you doing CXF, others doing front-end, some of us doing back-end. So it means that with a single Karaf runtime, we can address and implement different use cases. It also provides a lot of ready-to-use features from the Karaf ecosystem. So I heard some of you use Sera for the cluster. Some others maybe try Decanter for the monitoring, etc. So internally to Karaf, in the runtime itself, we already have a bunch of features available, but we also have additional features provided by other projects. And obviously, if we extend Karaf with Camel, with CXF, with others, with Udemy or whatever, then we can have a lot of feature out of the box that we can leverage to implement our business. Another thing that could be interesting, it can be used on-prem or on cloud. Again, you don't need a Docker daemon running locally. You can just use a Karaf container on your machine, and then moving this container to the cloud is pretty easy. And another thing that maybe don't really use right now, I know some of you does, but not all, is you have different kind of distribution and packaging. So by distribution, it means you can use the regular way of using Karaf. By regular, I mean you just create a Karaf distribution, or you just start Karaf and deploy stuff on it. But you also have another way, is a static distribution, where you can assembly a kind of Karaf directly running your application. So all these features, mixing all these packaging and all this stuff, you can implement really something that fits your business. And in terms of use case, we discussed about application, IoT, microservices. I guess Dmitry will share some usage and use case of using Karaf at Netflix, and that's very interesting to see the different use cases that we can implement with Karaf. And also we have some other features. So maybe some of you saw Karaf Decanter, which is a monitoring framework based on Karaf. So using Decanter, you can implement monitoring, alerting, business activity monitoring, and you can integrate with Drop Wizard, Prometheus, or whatever. So that's very interesting, because out of the box, without a lot of effort, you can also have integration with regular and classic cloud ecosystem. We also have clustering and Kubernetes integration, smooth integration using Sera. You can have repositories, so both artifact repository and Docker registry using Cave. So it means that maybe before implementing something and implementing the low level of what you need, maybe taking a look about what is provided by Karaf and the Karaf ecosystem could be interesting and give you a lot of gain in terms of implementation. So let's try to talk about application in Karaf. I guess most of you are familiar with OAGI. That's a way of using Karaf, and that's probably the best way of using Karaf right now, leveraging the OAGI feature like the service registry, the whiteboard pattern, etc. But just to let you know that Karaf is not only OAGI. I mean, you can deploy Spring application, you can deploy regular Java application. And just to quick highlight about the discussion about the roadmap, it will be even extended for the next release of Karaf. The purpose is, if you control AGI, if you know AGI as you do, so go ahead, you can implement in Karaf, that's fine. But for people that come from a different background and they want to leverage the feature provided by Karaf, it's also interesting to support all the framework. It's also easy to get from a middleware to Karaf if you have some kind of legacy application. With not a lot of effort, you can migrate to Karaf. So all this part allows you to implement a very different kind of applications in Karaf. So this is a very basic example. It's something that you implement pretty daily if you use Karaf. You just define an interface describing a service, and then you implement this service. That's fine. And then you deploy the implementation of this service, for instance, using SCR in that example. That's a way where you can implement efficiently some kind of microservices, and actually it's not microservices, it's more, for me, smart services in Karaf. So you can decide to scale this, this service or not. To deploy this application, right now you can deploy one by one. So you can deploy each microservices and dependency in Karaf running, or you can also package all these application and set of services using a feature. So another highlight that I wanted to share with you, and it's already really on the branch, this feature, you will have a choice between an XML feature, as you used to do, and a JSON feature. So you will be able to describe this application as a JSON, and actually this JSON can be generated easily with the new tooling we are preparing. In terms of integration and IoT, I think I saw Julian on this call. IoT is probably something that is really interesting in Karaf. Is the fact that, oops, sorry, I moved forward too much. But basically, integrating with Camel is pretty easy to create a Camel route and running in Karaf. Another thing that I wanted to share is, maybe you saw that in new Camel version, there is a new dedicated repository which is named Camel Karaf, and there are new tooling and new feature coming in this repository. So I didn't share yet on the main list, but we have new feature coming on around Camel in Karaf. Microservice is also very interesting and very popular. I know Christian has some kind of idea about grouping or whatever, but this is some example. The most important is to find the microservices approach that fit what you need. So you can use JAXA as whiteboard, you can use directly CXF declaration, you can use SELA or CXF DOIGI or remote service, whatever. The most important is, when you start with Karaf, it's pretty easy to migrate from an AGI service model to a kind of microservices. That's pretty easy. And the ramping of the knowledge ramping is maybe a little bit more high than all the framework, but honestly, I think it's more mature and scalable and ready to use. So this is an example of a JAXA as whiteboard. So that's a mix of SCR and JAXA as whiteboard. So this is a simple implementation of my booking service, where I just use a JAXA resource, and automatically this service will be exposed in my Karaf REST endpoint. Again, a feature that we need to deploy this application. And now we have one of the most important part of this talk is about the distribution. I guess that most of you are using the dynamic distribution right now. So it means that you are using the boot feature, you are using the startup feature, and all this stuff. So even you are using a standard Karaf distribution where you deploy your applications, or you are creating your custom application and distribution. But that's not the only way. Another way is to also to use the static distribution. So here, when we talk about that static distribution, we don't have the feature service anymore. We don't have the shell anymore, whatever. It's directly your application. So it means that it's pretty fast, it's pretty light. It's pretty close to what you can do with Spring Boot, for instance. So it's really your application. So basically, the big advantage of this approach is with Karaf, you have a choice. You can go with a dynamic distribution, or you can create next your custom distribution, and part of your application can be distributed as a static distribution. Is not a big deal. At the end of the day, what your DevOps is dealing with is Docker images. But that's it. So whatever it contains doesn't really matter. And the big advantage of static distribution is, in terms of code for you, there are no impact. It's just a different way of assembling the distribution. But the code itself, the way of creating your services, the way of deploying the services is still the same. So you can, it means that you can migrate your application from a dynamic distribution to a static distribution pretty easily. So this is an example of a dynamic distribution. By dynamic distribution, the workflow is you download Karaf, the standard distribution, you run Karaf, and then you deploy stuff into this Karaf runtime. So basically, you deploy, I don't know, you do feature report add with your application. So basically, you start, you do your deployment, and it's done. That's probably what maybe 70% of Karaf users are doing right now. Another way is, once you have your Karaf image, you can assembly and create your Docker image easily. So you have two ways of doing that. The first way is a script provided that allows you to create your own Karaf image pretty easily. So you just define what you want. So you can prepare your Karaf distribution locally, and then you create the Docker image. Or another thing that you can do, which is basically the same, you can install Docker and you do Docker provision, and then it will create directly a Docker image with what your running Karaf instance is containing. I know that on the main list, we had some discussion about improving the way of creating Docker images. So I fully agree. It's something that we have to improve, especially this one, the Docker provision. Actually use external volumes. So there are already an improvement on the way directly Docker image. So that's the first step. It works fine, but definitely we will improve this the Docker support. That's the first approach. The second approach is, this time is an extend to the previous approach. So it's an extend from the dynamic distribution, is to create your own distribution. So basically you can use the Karaf Melon plugin to create a Karaf distribution that contain your own application. So basically it's exactly like a dynamic distribution, but prepackaged. So prepackaged means that the system repository, so the system folder already contains your artifacts, and you can add your own features as no, but not plugin to create a solution is not as smooth as it should be. So we will improve this. Oops. Can you hear me, guys? Yeah?
Yes, now.
Okay,
looks
sorry.
like you had a bad uplink just a second ago. Sorry.
Okay, sorry about that. So yeah, I said we know that the custom distribution should be easier. I think today, for instance, there are too much dependencies in the way of using the scope, in the way of using the scope in Maven plugin, I mean, the way of defining the dependencies and all this stuff. So we know that it should be improved. And that's part of the roadmap that I'm going to share with you after the second talk. We will improve a lot the way of creating custom distribution to make it easier. So this is an example of how to create a custom distribution. So in this example, using the generate descriptor. So basically I create automatically the feature XML. Something that we should also improve, definitely. I mean, the feature XML generated is, in my opinion, too simple. So it will be better in the next release of Karaf. And another thing that I would like to share with you already is the fact that in the near future, with the new developer tool we're going to provide, we won't have to create a feature XML at all. I mean, it will be created for you behind the hood, and you don't have, actually, you're going to use some annotations. You're going to use some BOM provided by Karaf, and the new tooling will generate the feature XML for you, and actually, you don't know that the feature XML is there. So that's an improvement we are preparing. Once you have this, you can easily, with the Karaf Maven plugin, create the assembly, create the archive, create the Docker file up to the Docker image. So all is prepackaged, you are ready to go. And this will be improved as well, but you can already do that pretty easily. So that's the first approach. The way of using that is pretty simple. So here you can see that I created an archive. So I can directly start with a Beam Karaf. You can also use the Docker file, so you can create your Docker compose and Docker build pretty easily. And you can also have the Docker image, and you can see there that I can do Docker run directly, and it will start my dynamic distribution. Just a quick note, you can see there the -a-t that's required when you use the standard Karaf distribution, because you need a terminal to start the shell. If you don't want to start the shell, then you can use Karaf server, and in that case, the shell won't be started. And actually, that's the second approach that you can use, is the static distribution. In that case, it's exactly like a Spring Boot and the microservice approach. So basically, you create a Docker image that you just run, and once it's running, you cannot change anything on it. So if you want to change the configuration, if you want to update whatever, in that case, you have to do a rollout update. So basically, you stop your Docker container and you restart a new one. That's pretty easy with Kubernetes. And just to let you know that in Karaf, you can do exactly the same. So it's a build and run workflow. In that case, it's pretty close to what you can do with Spring Boot. And it's very convenient with the one, let's say, familiar with Spring Boot and the way of using microservices. I don't say it's a good idea. I just share that it's another way of using Karaf. So to do that, it's exactly the same. You start from your application using OSGI, using whatever is supported by Karaf. You create a feature XML. And the main difference is when you create the distribution, so basically your custom distribution, instead of using a framework, you use a static framework. That's basically the only difference. So here you provide a startup feature containing static framework. And in terms of framework, you are using static. And then when you do that, here I only run SCR, HTTP whiteboard, and my application in Karaf. I don't have a shell, I don't have a feature service, I just have this running. So it means that my Docker image is pretty light, the Docker run is super fast, and you are ready to go. You can leverage all features provided by Karaf. You just have to define here as a startup feature. So here you can see the difference. So at the end, you can still use a local running instance of your static distribution. The main difference is instead of running using Beam Karaf, you are running with Beam Karaf to run. Because in that case, you are running in static mode. And then if you use Docker, it's exactly the same. You can see there Docker run, and there I don't provide -a -t because I don't have any shell. it directly launches my Karaf instances with my application. So it's pretty light, it's pretty fast, and it's pretty convenient for the one who's coming from Spring Boot, for instance. So now we have our Docker images. That's actually where, as developers, we are good to go. Now the second step is more for the DevOps. Is I have my Docker image on somewhere, and I would like to run on the cloud. So here you have two ways of doing that. The first way is using Cloud VM. So if you are using Amazon, it's EC2. If you are using Google Cloud, the name is Compute Engine. If you are using Azure, it's also virtual machines. So that's exactly as you can do on your local machine. You create a virtual machine, you upload your Karaf distribution, and you start Karaf. So you can work with dynamic, custom, or static distribution. It doesn't really matter. So this is an example of EC2. So I created a virtual machine on Amazon, and I'm running my Karaf instances on it. You can see I'm using Amazon Linux, so that's fine, and I'm starting Karaf. Nothing new there. Is exactly as you used to do on locally. Now another thing that you can do. So the issue with the previous slide is I have a single machine, so I'm not serverless. I have to create my VM and all this stuff. So an improvement is to leverage Cellar to have some kind of multiple instances of Karaf running. Like this, I don't have a single point of failure, and I can sync my Karaf instances all together. So that's a step forward on EC2. Instead of having a single EC2, I have multiple virtual machines, and all my virtual machines are synced together using Cellar. Another thing that you can do is also to use ECR, ECS. So ECR is basically a container registry, and ECS is a container service. So on Amazon, basically what you can do is to create a repository, so basically an ECR. So in the repository is a Docker registry specific to your Amazon service. And then in this registry, you upload so basically you do a Docker push with your Docker image. And once it's done, you can tag, so I push on my ECR. And then when it's done, you can use, so you can see there I have my image ready on my Amazon cluster. And then I'm using ECS. So ECS is just running Karaf using the Docker image. So I use my Docker image, I run in Karaf. So this is just a container service. I don't talk about Kubernetes yet, okay? Just a container service. And then I have my Karaf running, and that's done. My Karaf service is there. I can add multiple Docker container like this. That's pretty simple to do, and so you can see there. You can have for one Karaf service, you can define multiple container, but again, it's not a scale, okay? It's like running multiple Docker container. So that's you can see the log. So it works pretty fine. You can see the number of tasks that you deploy on this cluster. And so the final approach is, so using SCR, you already have a Docker registry, so it means that you can create a Kubernetes cluster, and then your Karaf containers can scale, and you can have multiple replica for this service. So here I am on EKS. So EKS is the Kubernetes service on Amazon. So I created a EKS service, and then what I'm using the regular kubectl command. And so you can see that I push and I run my kubectl, so my Karaf Docker image running on Kubernetes. And here you can see the number of replicas. So basically, I'm starting with one Karaf, and then so I'm exposing a service on Kubernetes. So for the one who is not familiar with Kubernetes, you run some pods, and to expose a pod, you need to create a service on Kubernetes. And you can see there that I can easily scale up and scale down. So I have one Karaf running there, And using a serverless, I can define, okay, I need 2 new Karaf instances. So I just do kubectl scale, and I have 2. It's exactly the same, right? It's exactly the same Karaf image that I pushed. And so I can scale up and scale down pretty easily. So at the end, why Karaf is a good runtime for the cloud is, one, it's very flexible. I mean, when you use Spring Boot, you only have one approach, is the static approach. With Karaf, you have a choice. You can have the dynamic approach. You can create your custom distribution. You can use a static distribution. It doesn't really matter. At the end, what you do is the way of creating the Docker image. That's the most important. And so it's pretty flexible. Before passing the ball to Dmitry for the Netflix talk, I see some hands. Let's check.
Yes, I think there's been 2 questions, one from Maurice and one from Bernd.
Okay, so Maurice, go first. What was the question?
The main pain at the moment is we're working with Karaf archives, mainly for deployment, dynamic deployment on a self-built runtime environment. And if I need just part of, let's say, part of the Camel feature XML, I have no way of doing this in my Maven plugin. I always get the complete feature XML pushed into my own bundle XML. And is there a way to do that more selectively with the new style you just discussed?
So basically your point is today when you define the Camel feature XML as a repository element or even as a dependency, actually
I just build a project and I need Camel FTP. And if I build my car, I package my dependencies from my own project, multi-module Maven project, and I just need the Camel FTP. For now, I just copy and paste them from the Camel feature XML, because if the Camel Maven plug, the Karaf Maven plugin, if I do aggregate, feature aggregate, it always aggregates all features of Camel, and I only need the FTP one.
Okay, so basically that's the reason is because the Camel feature contain all the feature components, so the Camel feature repo. It would have been better to have some part, so I mean splitted features in Camel, feature XML I mean. So instead of having one big feature XML in Camel containing all the components, maybe it would have been better to have atomic feature XML per component.
Maybe this is not a Camel problem, but maybe the Karaf Maven plugin would selectively pick out the parts I need, so I don't need to have to copy paste all the stuff. Otherwise, you get one big car file with all of the Camel stuff in it and your own project.
Right. So I think that's a good improvement. The only thing that we have to check right now is when you define a feature that depends to another set of features, we have just to embed the transitive feature if you want. So yeah, that's not really possible right now, but because today we take all the feature XML contain, but definitely a good idea. Yeah? So feel free to create the Jira, or I will create it for you, but we can do that. It's pretty easy actually to do that. So yeah, that's a good improvement, sure.
Yeah, and I think also Bernd had a question about the way bundles are unpacked in static. In the static distribution.
Yeah, I just was wondering if we can use the static distribution to reduce the work done at startup time with temporary files, because that's always a problem for the Docker. So if I use the static distribution, will it still unpack all the bundles to a cache directory?
No, because actually, if I go back to this example, let me show you something that is very important.
Or is there a method to use that with the dynamic distribution as well?
So 2 points regarding to what you said is here. Oops. You can see in the use reference URL is true, meaning that actually we don't use the system folder at all. So it means that we're gonna directly use the jar file provided in. So it's actually in the system folder, but it won't be resolved at build time. I mean, all will be resolved at build time. If you talk about the data folder, maybe you talk about the data folder, right?
Yeah.
So the data folder is not under the Karaf scope, if you want. It's more about the framework. So basically today, Felix or Equinox are using the data folder to unpack the bundles. And there are no, actually, if you do, if you're using static distribution, that's possible to pre-populate the data folder.
Mm.
So that's
yeah, I agree
possible.
with Felix, but yeah.
And for about your question, is it possible using dynamic distribution? Yes and no. It's possible if you at least start the first time your distribution, because you will pre-populate the data folder actually. Does it make sense to do that at build time? It's something that we can do. I mean, we can add a goal in the Maven plugin to pre-populate the data folder. That's possible.
Yeah, I think that would be good for building containers.
Yeah.
Yeah.
Okay. Sounds good. Yeah. All right. So I think I'm on time. So I will stop sharing my screen. And now, Dmitry, if you are good to go, you can take the hand.
Yeah, I'm good to go.
All right. Can you share your screen just to be sure that it works? Sounds good.
Yeah, seems to work.
Yeah.
There it is.
Awesome. So you are good to go. So Dmitry from Netflix will share why they are using Karaf, in what way, and what their feedback about Karaf.
Okay, so I'm going to start. So the team that I'm with at Netflix is called Media Cloud Engineering, and what we are doing is we are processing various media like video, audio, text, images, and whatever else can be related to streaming content online from the point where it gets shipped to us by the studio and to the point where it can be streamed on any of thousands of devices that Netflix supports. So we also, in addition to that support content production. For example, while the videos or audio is being edited in the studio, and they need to do various transformations to it, like encode it, convert it. That's another use case. And encoding itself is a very costly process. It's very computation intensive, and that's why we're working towards efficiency and trying to reduce our bill for all this encoding that we're doing. So these are basically the primary functions and goals of the team I'm working for. So this presentation, I'm going to talk a little bit about what media processing workflow looks like at Netflix. And then I'll talk a little bit about the platform that we're building to support all this media processing and coding, and how we use Karaf to power some of the components of this platform. And I'm going to talk about cost benefits that Karaf gives us, as well as operational efficiency. So this would be a typical media processing workflow at a very high level. So we get a raw media, which is the outcome of work of the studio, and then we inspect it, whether it's good or not to go online, and we will be able to meet all the requirements and support all the devices with all the resolutions. Once all inspections are passed and they are good, we do all the transformations. So the source is going to be encoded into a huge variety of streams that would support different resolutions, different languages, different subtitles, DAP cards, etc. And that results into a multitude of different encodes and media files. And at the end, we get playable media, which is getting deployed to CDN and then can be streamed by Netflix streaming applications that are on different devices and used by users. So this is a more specific example. For example, this is how good a video encoding look. So the video is getting ingested. Then to speed up this encoding, we split it into multiple chunks. Then each chunk individually gets encoded in parallel. And once it's complete, we assemble it back into a single file. Then we apply other certain transformations, like we apply DRM keys so that we know, so that we basically could protect our content. Then it's getting packaged. Audio gets added to its subtitles if needed. And then it can be streamed. Then it goes to CDN. So how does the architecture with our current system looks like? This is basically, we are currently at third iteration of our workflow platform. The first one was very simple and was pretty much just a graph that would capture all the steps that I needed to transform the original source into playable video. The second one was more dynamic, and it was driven by rules. Basically, if a state of the encoding matches the rule, it would trigger certain actions and then move the encoding to the next state. And many of those processes are working in parallel. The third iteration is very similar to second in terms of concepts. There is still rule engine, and it's a forward chaining rule engine. Everything is dynamic. If you change your rules, then everything is going to get picked up from basically the state where those rules matched and continue working. A little bit more about the architecture. So right now we have this API, which is a Spring Boot application at this point, but we're also planning to move it to Karaf at some point. Then there is a rule engine, and this rule engine is powered by Karaf. And then there are work executors, which are pretty much Docker containers, which have some video encoding software. And once rule engine decides that there's something that needs to get encoded, it's going to send a message to work executors. Container would get spawned. It's going to do its job and then just shut down and report results back to rule engine. So these are basically how our rule engine looks in Karaf. We have runtime. What is a runtime? In a typical kind of microservice world, and in a typical organization that's leveraging microservices, there's usually a team which is responsible for providing a framework for service developers. The framework would include like certain libraries and certain services that are needed to support microservices. Those would be microservice configuration and then microservice discovery, because every microservice needs to register itself in the environment it's running in, and then so that other microservices could discover it. And also it needs to be able to reach out to other microservices to talk to. So this is basically what is provided by runtime team. In Karaf, we leverage this in my team, and specifically in Karaf, we leverage this concept and we package this runtime into what we call a runtime bundle, and we share it between different workflows. A workflow would be specific to a certain type of video encoding or audio encoding or text processing, and we have plenty of those workflows that are managed by different teams. So another bundle that we would have in our Karaf distribution is Workflow Manager. This is basically a supervisor which takes care about all the workflows, managing what version is currently running, and if I need to deploy a new version, how do I deal with that, and how do I shut down the previous version, start a new one, and make sure that it works. So what is inside workflow? A workflow would consist of a data model, which basically tells how would your state machine be described, and what are some of the results of the invocation of the workers that are captured inside this data model. And then there are also rules. Rules are written in DSL, which is based on top of Groovy, and pretty much once a rule matches against data model, a certain remote action would be triggered, some encoding will happen, and then the result would come back and stored into the data model. In addition to those two components, we also package into this bundle workload-specific dependencies. Those would be basically Java libraries that are not part of runtime and needed specifically by this workflow and nobody else. So more about Karaf and how we use it at Netflix. We started looking at Karaf a little bit less than 2 years ago, and basically we started doing this because we wanted to address various like specific microservice architecture problems that we had with our microservices at Netflix. So couple of those were operations and developer productivity. So when it comes to microservices, there's a huge number of them and different instances for different purposes of them that team would have to manage. And this is quite an overhead because there's a lot of different build jobs like Jenkins jobs and different deployment pipelines that push changes to production. And then it's quite hard to run end-to-end tests because many microservices, they talk to each other and they need to be accessible, and it's very hard to test something in isolation or on your local machine because you have to deploy all of them. So we decided that we want to have a multi-tenant system where we can deploy all of our workflows into a single instance, and we just manage this instance and we don't worry about the number of Jenkins jobs or pipelines or number of instances running somewhere in the cloud that we have to manage. And then we also wanted to simplify things like runtime deployment. As I mentioned previously, runtime is basically a set of libraries and services that are provided by runtime team. And once something changes in runtime, everybody has to rebuild and redeploy their microservices to pick up the changes. This becomes really painful when, for example, there is a bug in one of runtime libraries and it needs to get pushed. Then you will have to reach out to all of the owners of the microservices that use this library and ask them to redeploy their applications. And it's taking time because people are working on their tasks. They have their roadmaps, and especially it becomes hard when there are changes that they need to make to their microservices. So this is basically shared runtime that we have in Karaf, and then shared resources. Specifically in our use case, many workflows can be idle. For example, at certain step of the entire big process, this workflow is getting triggered. It does some work, and then it becomes idle while something else is working. And this was quite inefficient in terms of how we use resources. So we wanted to share them. Like while one workflow is idle, the other one can use those resources. And the next thing, the next basically goal for us was to share services. Services is for what I mean by services is configuration of a microservice, discovery of a microservice, metrics, monitoring agents, login facilities, and similar things that are basically infrastructure that is needed for a microservice to run. So this is basically runtime container and the model that we currently follow. We have plenty of workflows. We've seen up to 400 workflows running in our Karaf instance, and those are basically coming from people developing their applications. Like every developer would basically create a feature branch in the source repository and then deploy it to Karaf. And this is where all those numbers are coming from. And again, so many workflows, runtime bundle, management bundle, and OSGI framework. So for this new architecture, even though we were not initially targeting costs, but more developer productivity and operations as a side effect, we got a very significant improvement in terms of costs. And currently we're using only 10% of the costs that we were incurring with the previous iteration of our workflow platform. There are basically two pieces that contribute to it. One is we don't have many development environments because we can just deploy everything into one Karaf instance. And because development environments are typically with a development life cycle are very short-lived or do very little work. For example, you deploy to, you're developing a feature, you're done coding, then you deploy it to the cloud and you want to test it, you submit a few requests, and then this instance would be just sitting there till it gets destroyed by a sweeper. And we had quite a lot of those instances that are used very little, but stay there for some time, and basically we pay for them. And then the other one is reuse of resources and services. Again, if you're talking about deploying to an AWS instance or a Docker container, every microservice would get all those auxiliary services that it needs to properly function. Like it's going to go fetch its configuration from repository, and then it's going to register itself in discovery, and it's also going to get a map of all the services surrounding it, so that it could talk to other services. And with the number of services that we have, those resources become quite costly if you sum them up. And I show that later a little bit in the slides. So before Karaf, we had production environment, we had integration environment, and we had multiple development environments for every feature or bug fix that happens. There was a separate isolated development environment spawn, and basically used very little, sit there for a while and then just get destroyed. And the cost of those development environments were 4 times bigger than basically us running production and integration together. After we switched to Karaf, we were able to bring this cost to just 25% of production and integration together, which is a very good achievement in our scale. So next few slides will show basically how the resource utilization drops after we enable sharing auxiliary services that are used by a microservice. So this is basically after we moved few services into runtime and enabled sharing of those between different workflows. The CPU utilization dropped like from spikes to 40% to less than 5%. Memory usage, again, 60% gain. And another important component is networking, which pretty much from interface being saturated dropped to very little. And this is where many of those savings are coming from, and how Karaf helps with the costs in our organization. Okay, so operations. I'm going to talk a little bit about those because those are even of more value for us. Thing number one is keeping dependencies up to date. Again, since every microservice in a typical microservice world is deployed into a separate AWS instance or Docker containers is static. And once a microservice gets more or less stable, people pay less and less attention to it, and they're not keeping up with dependency updates that are coming from the runtime. And then pretty much somebody from runtime has to go and talk to service owners and ask them to update their dependencies. Sometimes those updates lag behind quite a lot. And at some point they would need various code changes to adopt new dependencies. And what happens is basically if they don't update or they don't find time to update it, that means that runtime team will have to support multiple versions of runtime and apply fixes, for example, security to all of those versions of runtimes that are being in use, which becomes quite inefficient and expensive. So with runtime, since we have this shared runtime bundle, all the workflows that are running inside our Karaf instance would get these updates, and we don't have to go to service owners and ask them to update. This is one of the big benefits that we see. Also, timing sometimes is critical because if there's impact in production and you have to update all of your microservices, that becomes really hard, but easy with Karaf. This is related to runtime level fixes or features. So managing less instances, that's a very big win for us because together with the instances and together with environments, less Jenkins jobs to maintain and less pipelines, deployment pipelines to maintain. Specifically when there are certain changes that need to happen. Like I'm going to give an example. When we were migrating from Oracle JDK to OpenJDK, we had to go and manually update like hundreds of Jenkins jobs to use the new JDK. This is very, very painful, and with Karaf again, we just need to pretty much update a few. Easier end-to-end tests. End-to-end tests in microservice world are basically done by either you're talking to some instances that somebody deploys for you somewhere in the cloud, or you're mocking other microservices that you are talking to. Now, none of those gives enough confidence to people, especially in our case, because in a typical microservice, there's an API call which produces some output, and you get it right away as a JSON or protobuf. In our case, a service call is first asynchronous, and it might come back half an hour later. And the second thing is we also produce not just the JSON response, but together with the response, which could be JSON or protobuf, we also produce files that are stored somewhere in the cloud, and which adds a lot more complexity. So basically the main concern for many of service developers was that they don't get enough confidence to push their changes to production with either mocking or using some versions of the services that are running in the cloud. So if the entire system is big enough, it's really hard to deploy an isolated environment, because it will require you to deploy dozens of microservices and then run your end-to-end tests and then do all those verifications. And the other thing is, it's hard to basically figure out if something goes wrong in the test. Why is it failing? Is it because of my service or someone else's service? Or it's hard to manage also versions of, am I using the correct version, or is it version which is in production, or is some other version which is not in production yet or was in production 5 days ago. So with Karaf, basically you can just easily and quickly deploy all those microservices as bundles into a Karaf instance, and you get a clear picture of what's going on in the isolated environment. And it makes basically the testing a lot easier. And this also applies to local development. You can just start your Karaf instance on your local box, deploy all your microservices, set your debug points, and basically see what's going on. Some trade-offs. All those benefits basically come at some cost. So one of the things that is not that easy, if all your services that are running currently in Karaf instance are built against a certain version of environment, and then you need to make backward incompatible changes to this environment, this becomes harder because now every service has to pick those environments up. This was one of the challenges that we had. So we decided that for cases like this, we would just maintain 2 versions of, or 3 versions, or whatever the number of versions is needed of runtime, and to give people time to pick up those changes. But so far, we have never used it. So safe runtime releases. When you release your runtime, how do you make sure that you're not breaking anyone? Because even if the changes are backward compatible, there could be bugs. Basically, what we do is we have a pre-production environment, and all it does is it just takes all production bundles. It resolves all the workflow bundles again, the newly released version of runtime, and then starts all the bundles and does a health check on them, which pretty much, if all of those steps are successful, we are confident to release runtime. A big concern that was coming from many of service developers is computational resource control, because when you are inside an AWS instance or inside a Docker container, you are basically limited only to this AWS instance or Docker container, and you cannot go beyond all those resources. Since all of the workflow bundles are running inside a single JVM, there is no way for us to control like how they are using resources, and there is a chance that if one of them has a memory leak, for example, this would just consume all the memory on the box and affect all other services running. So again, we haven't seen it so far, but it might happen. And we thought about a couple of solutions. One thing, if we figure out that some of the workflows are more resource greedy than others, we can just deploy them in their own Karaf instance, which basically brings us back to the old model of deploying microservices. But if it's justified, that's fine. And then the second approach that we're looking at is basically to do something like distributed databases do when they partition data and make a copy of certain partitions on different instances in such a way that they don't overlap. For example, if you have 3 copies of data or 3 copies of a workflow running in 3 instances, they wouldn't overlap all of them with some other workflow running again 3 copies but on different instances. So let's say if one workflow uses too much resources, then it's going to affect this specific instance but not the other 2. So troubleshooting, this is more of a learning curve rather than inconvenience for us, but it was because all the workflows are running in a single Karaf instance. It was sometimes hard to figure out which workflow is doing what and how the entire environment is impacted by what workflow is doing. And but after giving it few tries and basically figuring out how to properly log things and how to properly report metrics, we were able to get around of this. And yeah, Karaf, we are fairly new to it. It's only going to be 2 years for us this summer of basically running Karaf. So for us, it was a lot of unknowns. It was not a paved path that Netflix showed us, but thanks to basically JB specifically and Apache community, we got a lot of help. So we were able to get through this learning curve. And yeah, we are quite happy at this point with our choices. We are very satisfied with the results that we are getting, and we're looking to move more applications into Karaf. Okay, this would be it for me.
Thanks, Dmitry. That's really awesome and impressive. There are some questions during your talk. There's a question from Greg, who asked, what did you use before moving to Karaf? It was a homemade application running on Spring or fully Java homemade? What did you use before?
So it was again a homegrown solution, but it was packaged as a WAR file and was deployed into Tomcat.
Okay, got it. All right. So, and back about your trade-off, I fully, I think it's a great transition to the next part, which is about the roadmap. First about the resource control and isolation, but something that it's a classic question in Karaf. And I think we will need some kind of internal orchestrator inside of Karaf dealing to the memory and CPU we can assign to one bundle. I think it's challenging, but will be possible. And it's something that I think if we have more and more of a question, it's something definitely we have to address. And having an internal orchestrator inside of Karaf could be interesting. And the second thing that I wanted to share with you is I fully agree when you said it was not a private path. It's difficult. Sometimes it's not easy to start with Karaf. I think we did a lot of improvement in the examples we provided, but example is not enough. I mean, we need something more, I would say, straightforward. And that's exactly what I wanted to share in terms of roadmap. So if you don't mind, Achim, I will take the end again.
Yes, sure. Go ahead.
Thanks. So let me share my screen again. All right, there. So let's back there. All right. So in terms of roadmap, again, it's just ideas. Some ideas already started. Some ideas depend on you guys. I mean, it's a fully open project. So if you have ideas or all the features you want, Tony mentioned something very interesting on the chat during Dmitry's talk. He said Karaf should not go on the microservices approach as Spring Boot. He should go as a kind of modulo. How did you say, Tony? Modulate. So module and
well, yeah, the expert term is modulist, right?
Modulate. So and I fully agree. I mean, today, and I saw an article yesterday, I think, about a company named Segment. So Segment is an Australian company around CDP, and they went to microservices, very deep in microservices, and now they are going back with not really monolith, but as you said, Tony, is a monolith. So I think it's interesting, and it's where we have to go, and it's exactly the purpose of the Karaf runtime. I don't think it's a good idea to chase Spring Boot. If people want to do Spring Boot, that's fine. But one thing we have to be clear about Spring Boot is today, in terms of developer experience, it's largely better than anything we have in OSGI or in Karaf. I mean, even if you take today BND tools or whatever, it's not as straight as Spring Boot. So I don't say we have to follow Spring Boot approach, but I say it could be inspiring for us in some part of the developer experience we have to provide. And something which is clear in Dmitry's talk, and something that some of you share in the introduction, is once you have Karaf running in production, it's rock solid and it's fine. It's stable. It just runs fine. But to go there, to go in production, and to go in my application running in production with Karaf, that's not easy. And I hear that. And so that's exactly the purpose of the Karaf runtime. So short term, we have the release cycles, so the 4.3.0 release, the 4.2.9 release. As Greg said, you're working hard on Spax Web for 4.3.0 release. And different improvement. As I mentioned during my talk, we have also a better, easier way of creating distribution, improvement about Kubernetes experience. But the core of the runtime, and where I think, that's my standpoint, maybe you have a different one, and I'm completely open to discuss, but my target is really the tuning and the developer experience around Karaf. So easier to create application, easier to create feature. Do we really need feature or not? That's something that we have to move forward. We already started kind of POC. Maybe you saw on the main list, I already shared some teasing about that. So Francois and I, we already start to work on something named DevX. So DevX for developer experience. But the purpose is really to share with you something that is usable and something that you can try and to see if it matches your expectations or not. So definitely on the roadmap of Karaf Runtime itself is all about the developer experience. Obviously on the other Karaf ecosystem, we have Stellar maybe you saw that on Karaf Cave, we did a complete refactoring of what was Cave. Now we plan to do the same on Stellar to have a better support for Kubernetes API directly, to have Ignite and Hazelcast support, so that's on the way. Decanter, you probably saw this morning, there's a new version of Decanter coming with new collectors and appenders. We're going to provide more, for sure. We have some users that ask for running Decanter. I don't say non-OAGI, but inside an application which is not OAGI native, just because they want to leverage Decanter features and K features. So it's something that we can address using either OAGI Connect or OneGrower. It's basically the same in terms of purpose, not in terms of implementation, for sure. So that's some highlights that I wanted to share with you. If you have different standpoint or if you want other features, please let us know. Again, it's an open project. Personally, I'm really eager to get your feedback about what we discussed today, about what Karaf should go, and that's really interesting. So just raise hand. I mean, I'm listening, and we are listening actually.
Well, thanks, JB. Yes, I think I've seen a couple of questions in the group chat. So why don't the people just raise their hands? Again, use the participant list to raise your hand. There should be a button with that. So we can go through the people and go through your questions. I think there's been one question asked about why there is Hazelcast support on Karaf Stellar, because that is already included, isn't it? JB, you're muted. Still
sorry,
muted. Yeah, there you go.
Sorry about that. So yeah, Hazelcast is already including Stellar. That's true. My opinion is today is too much deep dive in Stellar. So basically, what I want to do is to have. We already have some facing API facing Hazelcast, and I would like to be able to leverage Ignite. But the thing is, we only use two parts of Hazelcast today. We are using the pub/sub approach and the distributed map. So the purpose is to better leverage all the feature provided by Hazelcast right now, especially around Kubernetes. So that's true. Hazelcast is already used by Stellar. The purpose is to improve the support of Hazelcast features.
Okay, in the chat we also had another question, I think from Thomas Dresen. Do you want to do that your own, or should I read that?
So let me take.
Thomas is yeah.
Yeah. It was regarding WineGrower and how do I switch from a now OSGI setup, development setup, to a WineGrower setup? Would it be easy, or are there some pitfalls on the way?
So yeah, that's a good question. So basically, WineGrower it implements completely the OSGI specification, but the big change is the fact that today we only use a single class loader. So instead of having one class loader per bundle, as OSGI framework is doing, we always have a unique class loader shared by, and the scanning is done at the beginning. So as soon as you start, we scan all the jar file you have, and then you are all these in the same class loader. But you can still use your activator, you can still use your service registry, all is implemented in WineGrower. The purpose of WineGrower is to be able to run WineGrower in your application, or the opposite. You can do both. but basically you just run a main class, but that's it. So you just run a bean and it's done. The big advantage when you do that is you can mix in the same class loader Spring applications, so basically Spring XML or whatever, in the same class loader as OneGrower. So the purpose of OneGrower is to be able to easily embed. It's exactly like creating a Karaf static distribution embedded in your application. That's the purpose of OneGrower. It's the same idea as OSGI Connect. The thing is, we started OneGrower before the specification. And so we created our own view on about OneGrower. Does it answer your question?
Yes, thanks.
Okay. Do we have another? So
yeah.
There's another question, I think, about Spring. I saw on.
Yeah.
No.
Serge Demoulin. I'm sorry, I'm not a native French.
I am.
Okay, you go ahead.
So the question is supporting on Spring class path scanning. So again, there are two things. Today, you can already deploy Spring application in Karaf, but this Spring application will be in its own class loader. So meaning that you cannot see beans provided by all the Spring application provided another bundle. So here we have two approaches. The first approach is to use a kind of, and it's something that we discussed with Dmitry and Said at Netflix, is to have some kind of Spring specific deployer that allows you to gather all Spring artifacts or Spring application together in the same class loader. So that would be possible.
But you have to have Spring inside the bundle, or?
Yes.
Yes, but there is some issues with the class loading of Spring, I believe.
Today, yes, because each class loader are different. But if you gather all in the same class loader, that's fine. And in that case, you can use OneGrower. OneGrower is exactly for this, because all will be in the same class loader. So you can mix in the same, with OneGrower, you can mix Spring application with your application. But in any case, to be able to support and to leverage the Karaf features in Spring application, we will need a specific deployer and improved deployer compared to what we have right now. So basically, when you deploy a Spring artifact, whatever the Spring artifact is, it should be hand in the kind of Spring class loader where all is deployed. And in that case, it would work.
Yeah, I need more information on that, but after.
Yeah, okay. That's good. Any other question?
Yeah, but best to raise hand, please. I think there's a couple of questions on the chat, but I'm kind of lost. So please raise your hands and ask those, please.
I agree with that, and it's pretty hard to follow on. It's hard to follow on. Maurice, go ahead, Maurice.
I have to find the unmute button. Yes, how I understand OneGrower is what you say for wrapping up existing applications with a complete setup, getting kind of a big ball of mud into one bundle, you deploy on Karaf, and that's about it.
No, you don't. OneGrower is completely split from Karaf. So when you use basically OneGrower is you can run your bundles directly in OneGrower. We don't leverage Karaf at all. The only thing we leverage in OneGrower is the Karaf feature and Karaf bundle. But OneGrower is not supposed to run in Karaf. It's directly to run on its own. To be honest, I don't know if it's a good idea. Okay, just an idea about OSGI Connect and the way. For instance, imagine. You are running your Java regular application using Spring Boot or whatever, and you want to leverage decanter. Okay, you want to use collectors and extra. Today, if you want to do that, you have to in some way embed what for instance, what Christian did is to use Felix Connect to embed decanter inside your application. But again, you have a full framework running. So you have to start Felix or Equinox and deploy your bundle, extra. That's an overhead. So the purpose of one grower is to be pretty fast, to be very thin, providing all the OSGI model, but as a pure bin in a single class loader. But that's the idea.
That should run into Spring Boot or something else.
Exactly.
Cool, thanks. I think Paul raised his hand. I'm not sure if he still wants to. Just give us a sign.
Yeah, I will. My question is, what's the likelihood of running Karaf in that suite of applications in a Raspberry Pi K8 kind of cluster environment and for a lab or an education setting?
It's already what we did at UPeak. I know that Christian has some Raspberry running on Karaf. Definitely it runs fine. We support ARM, so but even if you have a ARM CPU, that's fine. The only thing that we did, I'm talking for our use case, it's to create a very light custom distribution of Karaf, just to remove all the unneeded stuff we didn't need actually. So that's the only thing, but it runs fine. So you can create your cluster, your Karaf cluster running on Raspberry or whatever. That's pretty easy. Yeah.
Thank you.
All right, I think we are good. So let's start. So thanks a lot, guys. So Arim, you take the hand to wrapping up. We can do both.
Yeah, sure. That was a pleasure. Thanks. Thanks for all the people to show up here on this first virtual Apache Karaf meetup. Hopefully, we'll have a place somewhere in the near future where we can all meet in one place and have a beer and a pizza all together. This is something I really long for. Yeah, right now we're 42 people, magic number, way to go. We started somewhere around 50 more, so thanks for all who participated, and this was great to see such a good, big community. Thanks to all the people, and thanks to Netflix people for showing their use case. I think it's very awesome. I really would love to see, yeah, a success story on the Apache Karaf website about Netflix and how they reduced their cost by 90%. That would be awesome. I see a lot of questions on the group chat. I would like to invite everybody to take those questions onto the Apache Karaf mailing list. I'm pretty sure that a lot of people around the world that are able to answer those questions and give some more details better than on this group chat here. And of course, please be invited to give us some ideas. If you want to present something, give us ideas where you're using Karaf, and so we can have a lot of nice, interesting ideas for the next Karaf meetup that we will do either way, maybe virtually, maybe on-site combined with virtual attendance. So we can have people from all over the world. So yeah, this is an invitation for everybody.
Just one thing, Arim, but I wanted to mention, there are still, you can imagine with a current situation in Europe and in the US, the next event is pretty hard to plan, but just to share with you that the ApacheCon Roadshow, which is supposed to be planned in July, will be probably virtual as well. And we will have a Karaf track during this European workshop. And also, so the next ApacheCon North America is supposed to be end of September, beginning of October in New Orleans, Louisiana. But it's not yet sure if it will be possible or not. But in any case, virtually or in the US, we also have a Karaf track there, as we had in Vegas last year. So yeah, that's really interesting. As Achim said, thanks all of you guys to have time to attend and to share your ideas. Don't hesitate to send on main list on Slack or even direct email any ideas, proposals, whatever you have in mind. A big thank to Netflix guys and Dmitry especially about the slides he shared and the feedback about Karaf. So just to let you know that, to be honest, we had our time, I think it was 2 years ago, Achim, as far as I remember, with Karaf. We were a little bit alone, couple of guys working on Karaf, but we never lose the faith. We really thought since the beginning that Karaf is the perfect runtime, and it's it's an hidden gem maybe at Apache. I hope so. Yeah, so just share your ideas, share your proposal, your feature, again, anything that you think it's interesting for Karaf. And yeah, let's try to make an even better product.
Thanks
and
a lot.
Thanks, Achim, for your help again.
Of course, you're welcome. And I will now stop the recording.